Hi. Hi, we are the team of front-end development for the multi-party computation in the cloud. The team members are Qingxin Li, Yicun Hou, Haoyu Xu. Our mentors are Joseph, Gagan, George, Rebecca, and Marine. Because of the hospital's limited computing capacity, it usually takes hours or days to get a medical image. We all know that for the patients, sometimes timing is everything. In this case, cloud computing can solve this problem, and that's the reason of CRIS. CRIS is an open-source medical image processing system using multi-party computation technology to protect patients' privacy. It has already deployed to the Massachusetts Open Cloud and used by neuroscientists, radiologists, and researchers. Here is a detailed diagram of CRIS system. Basically, there are 4 units. The data source, usually in the hospital, the CRIS store, the CRIS UI, and the computing environment, which would be like the Massachusetts Open Cloud. In here, I want to introduce a terminology called plugin. Plugin is a containerized set of image processing software. For example, while using Photoshop, you may need to filter the image or adjust the contrast. Each function is just like a plugin of CRIS. Actually, you can treat the CRIS store as an app store, and users can take the needed plugins from CRIS store. While using the CRIS system, CRIS UI will take the data from the data source and push it to the computing environment. Then the user will select a series of plugins from the CRIS store for the image processing. At the same time, the CRIS UI will push the plugins to the compute environment as well. After the calculation, the MOC will produce an output and push it back to the CRIS UI. Then the CRIS UI will display the calculation results. The CRIS store actually provides a platform for the third party to develop medical softwares. So our main tasks are in the dotted line area. And these red lines represents the data flow. Here are our plans for the project. Since our main goal is to help the CRIS team develop the front end of CRIS and learn how to use OpenShift, we will write the type declaration file for the CRIS UI to provide the object-oriented programming support to the CRIS team. Then we will write the script to test CRIS API to make sure the data flow between front end and back end is working normally. After this, we will try to deploy the CRIS store front end and back end to the MOC using OpenShift. Finally, we will stress test the CRIS store and try to improve the performance.
So for the CRIS store part, we first rewrite the CRIS store by using Redux. Why do we need Redux? Redux is a state management tool. For other frameworks, it will get messy as the application gets complex. But the state of the application using Redux will be easy to manage and maintain because there are a store to control all the state. In this picture, there are 4 different components. The actions is an abstraction of the user's behavior, and the store is the center to pass new state to the view, and view will re-render the state. And reducers will receive the message of actions from the store, and according to the actions to update the state and then return the new state back to the store. And the next, after we write the CRIS store, we deploy the CRIS store to MOC by using OpenShift. For the front end of our deployment, we used source to image process. Source to image is a framework that makes it easy to write images that take application source code as an input and produce a new image that runs the example application. While users use source to image to deploy their project, they need to give the project Git locations. And then the builder will combine the builder image that user requests to use with the source code and go through all the steps that are needed to turn the source code into a runnable application and commit it as a new Docker image on your system. After that, it's up to the developers. From there, they run the Docker image or push the image to the Docker registry to accessible for another system. And then is our backend deployment. This is the whole process of our deployment. According to the Docker file, which is a file to tell the Docker the steps to build a Docker image, we can get the Docker image of Chris store locally. After sending this image to the Docker Hub, we will deploy it to MOC together with other two different images containing two different services. One of them is the database service, which is MySQL, and another is the Swift service. And then we would connect them together by making them into one network and declare in a configuration file. And then I'll show you how we deploy it according to the Docker file like this. And then open a terminal. Enter the path of your project, and then use the command like this. And you can build the Docker image locally. Because the build will always take some time, so I just skip the whole process and then I will show the result. Here we already built the Chris store image, and then we can push them to the Docker Hub. It will always take some time, so let's see the part we already deployed. This is our database. We just use the deployed image from MySQL file, and then we can find them. And then here we need some environment variables. I already set. This is the password, the user, database name, or something like that. We have to set that to make sure our Crystal can connect to the database. And another service is the Swift service. There are no other environment service here. We just need to use the same method to deploy the image into our MOC by using OpenShift. And then here we can see our Docker image already pushed to my Docker Hub. Okay, after the deployment part, we then do the stress test for the Chris store. For the stress test part, we use JMeter. JMeter is an open source software designed to load test functional behavior and measure the performance. For a website, we mainly want to track and test the responding time and the throughput of it. So we will use JMeter to track these two information mainly. This is the result of our test. For the upper part, we used 2000 threads and let them run 10 loops. And they are all parallel, sending the request to the Chris store. We can see from here, when we only run 20,000 examples, the error rate is 18%. And the throughput is like 800 per second. And that's okay for our Chris store, but to make sure it was not a random test, we test another for 40,000 samples, and the results are similar. And for these two charts, on the right is the result when I was using 2,000 threads, and on the left is the result when I use only 500 threads. And we can see the maximum responding time here For the left chart, it's only 300 milliseconds. And for the chart over there, we can see the maximum responding time is approximately 1,800 milliseconds. So even if we send 2,000 threads at the same time, our crystal will respond to the request less than 3 seconds, which means it can handle the reasonable number of visitors. It meets our requirement. So the test is good.
So what we did about quiz. First of all, we created some declaration file for our quiz API. Our quiz API is written by JavaScript, which has many limits. So we want to migrate the JS API to another kind of API, which is called TypeScript API. By using TypeScript, we can control the usage of APIs when developing by defining the type for each function, variable, input, output, and etc. So now I will show a quick demo on how we write TypeScript declaration file. So as you can see, this is our quiz API homepage, and I will show you our quiz API by just choose an example. So here this is the first example. It's called get error messages. In this method, we found that the parameter's name was collection and the type was object, and the function's return type is string. So now we can just define our first API declaration file by this. In our code is like this one. This is our declaration file. In this one, we can see that we can just define the parameter type and the return type for the API. So that's all we did about our declaration file. So back to what we did about quiz. The second thing we did about quiz is that we do some API test for our quiz API after we writing the declaration file. For Redux projects, actions and reducers are abstraction of users' behavior and state changes, so we test them to make sure that our quiz API works well. Because quiz API exist in Redux, so we can conduct some tests on two parts of Redux. One part is reducer, and another part is action. We created the test API in Redux for 5 parts, which are feed, message, plugin, UI, and test. For each part, there contains their own reducer and actions. So as you can see, this is our test file, and in the test file we have 5 components. As you can see, it's a feed, message, plugin, UI, and user. And each component we have 2 .ts file. One is action file and another is reduce file. So this is our files infrastructure. So what technology we use to test our code? Actually, we use Jest, which is a delightful type JavaScript testing framework with a focus on the simplicity to test our code. Jest can work well with projects using TypeScript, Node, React, Angular, Vue, and more. We just run npm test in our command line, and then it will automatically find the test files and do all the tests. So I will show a quick demo on how we run our code in our project. So as you can see here, I can type npm test in the command line and wait for the result. And we can press A to run all the tests. And you can see that all the tests are passed, which means that our test file are write correctly. So that's all. So how did Jest works and how Jest test the code they want? I will give you an example on how we did our API test. So in the action.test.ts file in the message directory, we test our first function, which called UI on before request in Redux. We do the test by first describe what we are going to do in the test. It's like this line. And then we create an expect object. And this is our expect object, which is called expected action. And to check if it is equal to the original function we use is the UI on before request function. And we can achieve this by using metric keyword like the expect keyword. And in this function, we just test the action type, but there are lots of tests which we can do more about the type. And another example is about is the action.test.ts file in the message directory. And as the same way, in this file, we check two things. One is about the action type for our code, and second is about the payload of this function, and it works well. And when we design our tests, but due to the time limited, I will just show the basic usage of Jest. And for further usage of Jest, you can check the official website for more details.
Wrap up. From this project, we learned React and the importance of APIs in the cloud computing. We also learned the importance of TypeScript and strongly typed UI applications. I think the most exciting part is to deploy the web application by ourselves. It is really interesting to learn and compare different deploy methods of OpenShift. It is also a good practice to test the application performance, since lots of radiologists will use the Chris platform, and we all want to provide a stable image processing service for them. In the end, we want to thank for the professors who gave us talks during this semester, especially Professor Oran. We also want to thank for our mentors, since they provide a lot of valuable advice for us. Thank you.